Yeah, okay, hello everybody. Today, continuing our previous session, we're going to talk about linear correlation. Basically, first I will give you the definition of correlation, what do we mean by correlation, and what is the definition of correlation coefficient, which is a coefficient to quantify the correlation. And then I will give you some hints how to interpret the value of correlation coefficient and how to access this coefficient using scalar plots. This is basically a qualitative and graphical way to show it. And finally, I will give you the formulation to compute this coefficient. Generally, correlation coefficient is a number to describe the relationship between two variables. And it's quantified using two aspects, two factors: the magnitude of this relationship and the direction of that. The magnitude talks about how strong this relationship between these two variables is, and direction shows actually it would be positive or negative, which shows if variables are moving in the same direction. In other words, if we increase one of the variables, the other one increases. If this happens, it's positive direction, and if variables are moving in opposite directions, we call it negative direction. There are actually a couple of, many coefficients introduced in mathematics, but we use Pearson product moment correlation coefficient, which is shown by R. It is also known as rho xy and also correlation of xy. So these are actually different ways to show this, to represent this coefficient. And it measures the linear correlation between two variables. So today we are just going to talk about the linear relationship. I'll talk later what do we mean by that. So how do we interpret? Before actually showing you the formulation, I just want to show you how we interpret this correlation based on its value and its sign. Actually, this correlation coefficient ranges between -1 and 1. So as you see in this axle, we could interpret the magnitude and the direction of correlation coefficient based on its value. So within this range, if we go through basically the absolute value of this coefficient shows the magnitude or strength of correlation, and its sign shows direction of that. So going far from 0, as you see in the picture, means the correlation or the relationship increases because the absolute value increases. And then in the left hand, since the sign is minus, it shows that the relationship is negative. And in the right hand, it shows the correlation is positive. So based on the value of correlation coefficient, we could find to what extent the relationship is strong or weak, and then what is the direction of this relationship. Again, for interpreting this value, I just bring some scalar plots to talk a little bit about this correlation coefficient more graphically. The concept of linearity. Linearity, we say linearity exists when the pattern of the data follows a straight line. So the more this data follows a straight line, the more they are related to each other. So for example, in these two pictures, in the left-hand side, the data all are positioned on a line. So they completely follow a line. So I could say in this picture, these two variables, x and y, are completely correlated to each other. But on the right side, the picture shows that the data are a bit scattered more. So they still have sort of linear relationship with each other, and they follow. You could sort of recognize it, line they follow. But they are more scattered, so the relationship is a bit less.
Question. So does this relationship has to pass through the origin?
No. It's just one line that represents the old data. It could be any line. It shouldn't just pass the origin. Okay. Yeah. Okay. Talking more about the direction. Again, here I have two scatter plots. As you see here, the data shows sort of. Actually, the data follows a line which with positive slope. So we could say in this scatter plots, we could represent the direction of this relationship based on the slope of the line which represents the data. So in the left-hand side, the data shows a positive direction. In the right side, as you see, the line has a negative slope. So it basically shows that our relationship is negative. As you see, for example, by increasing x value, the y value decreases. So these are the ways, using some graphical, these are basically graphical ways to show the direction of our relationship between two variables. What about the strength? Are we able to, evaluate the strengths of our relationship using scatter plots? Well, yes. Basically, the strengths of relationship could be shown by how close our data are to the line that is fed to the data. For example, in the left side, all data are completely positioned on the line, so they are, the closest way happens in this picture. So we have the maximum correlation, maximum positive correlation. As you see, the slope is positive, so we call in this picture we have the maximum positive correlation, and the R is equal to 1. As you remember, there are two extreme relationships where -1 and 1. And then in the right side, we have again the maximum negative correlation. The slope is -1, and again, in terms of just absolute value, which represents the magnitude of relationship, these two are both the maximum ones. I'll show you some other pictures here. For example, having the positive correlation, in both of these pictures, we have positive correlation. This one, as you see, data are a bit closer to the line than this one. So the value of correlation coefficient is higher than this one. And both of them are positive. The same example for negative correlation. So you see here again, the data are more close to the line rather than this one. So the correlation coefficient of, in this picture is minus, for example, 0.8, and in this one is 0.5. In terms of the value, this one is mathematically larger than this one, minus 0.5. But as you remember, I said the strength of the relationship is about the absolute value. So in terms of absolute value, this one has bigger correlation or bigger relationship rather than this one. Okay, so any questions so far? Okay. And finally, zero correlation. So what do we mean if zero correlation actually means there's no relationship? We can't recognize any linear relationship between two variables. So when this happens, for example, in left-hand side, as you see, we have some random data which shows a random pattern. So when we plot the line, we show that its slope is 0. So this means that actually there is no relationship between our variables. Actually, we are talking just linear relationship. The next example is curvilinear example. In this picture, it's actually interesting. If you just look at the left-hand side, you could sort of recognize a positive correlation between these data and then negative correlation between these data. So in terms of just non-linear relationship, there is a very good non-linear curve which fits to this data. But just talking about linear correlation, overall the correlation is 0.
So yeah. If I have every data point on a horizontal line, that means R is equal to 0 as well. That
Excuse me, I didn't get.
Every data point is on the same line, but the line is horizontal. The slope is 0.
The slope is 0, yeah.
Yeah, so it's positive. You could say
Exactly.
Okay.
You know, it means exactly, you know, when, for example, all data is horizontal, it means that no matter what x value is, y value is going to be constant. So this means that there's no relationship between them. You see?
Okay.
Okay, let's give you some examples to understand this concept a bit more. So let's have we have this data set, and we want to just qualitatively talk about its linearity, magnitude, and direction before just quantitatively measure the correlation. So what do you think? Do you think if there is could you recognize any sort of linear relationship here? We could say yeah, because you know there is sort of a line that we could fit to this data. So in terms of linearity, we could say yeah, there is a linear relationship. How about the magnitude? Magnitude, as I said, talks about how close these points are to the line. So you could see they are a bit close. So just qualitatively talking, we could say the magnitude of this relationship is strong. And what about direction? Direction is almost obvious. You see, the slope of this line is negative, so we have negative relationship here. So direction is negative. So overall, we call this relationship strong negative correlation. In the next example here, as you see, this is kind of like the zero correlation. Just looking at the data set, we can't recognize any sort of positive or negative relationship. It is kind of, you could just again recognize the sort of line, but the line has zero sort of slope. So again, we could say this is linear. We could recognize some sort of linear pattern through this data. About the magnitudes, you see the points are a bit far from the line. So you could again qualitatively say that the magnitude of this relationship is weak. And about the direction, as you see in the line, direction is 0. So finally, you see the value of correlation coefficient is 0. Okay, after qualitatively talking about how to interpret and assess correlation coefficient, I bring here the formulation of this correlation coefficient. Here, as I talked before, we just use one of the coefficients in the mathematics. It's called Pearson correlation coefficient. It is basically defined as the covariance of x and y variables divided by standard deviation of x times standard deviation of y. So I just recall, just for you to recall, I just wrote the mathematical formulations of the covariance and standard deviation, but I'm sure you remember that because we talked about in our previous sessions. Okay, here is an example how to compute this correlation. Let's say we have a data set for x and y variables. We have just 4 observations for each of them. So I've just calculated the value of x, y, and then as you see, I have brought some calculations to find finally the correlation coefficient. Here is the summation and mean value of x and y, and the value of x times y, and these values. As you remember, we use these two values to find the covariance and standard deviation. So this is just the process how we calculate correlation. And finally, using this data set, I find the covariance of x and y, which is the mean of x, y. If you remember, it was this value 8 minus mean of x, which is 2, times mean of y, which is 3. So it's basically equal to 2. And about the standard deviation, you have this value, x minus mean of x squared. So we just need to find the expected value of that, which is here, which is 2. And expected value of this variable is here. So we could just easily find the standard deviation of x and y. So finally, having all these variables, we find and calculate the correlation coefficient, which is this value. Okay, I think
That's 5 minutes.
5 minutes, okay, yeah. I bring some questions for you to think about it and then answer the questions in the next session. The first question is, we talked about the relationship between two variables. So why would somebody be interested in finding this relationship? Why is it important to us to find a relationship between, for example, X value and Y value? This is the first question. I think I ask you to talk to think about them, and possibly if you could find some practical examples for that, it would be great to bring it in the next session. The next question is actually sort of philosophical question, which says, here we talked about correlation analysis. What is the difference between correlation analysis and the cause and effect analysis, which is sort of philosophical term? So does it mean the same? For example, when we say the relationship between X and Y is strong, does it mean that, for example, one of them is the cause of the other, or it's something else? So think about these two questions, and we could discuss about it in the beginning of next class. And this is the next session's topic, simple linear regression. So I will talk about it later. Okay, thank you so much.